Welcome back, everyone, to the live coverage here at theCUBE at MWC26, formerly Mobile World Congress. I think they changed the name. I'm John Furrier, host of theCUBE with Dave Vellante, who's out on an assignment right now, getting the action on the show floor, getting all the data, share with you. This AI wave hitting telecom, a hyper-converged edge is coming upon us. That's going to change the game on the infrastructure, the architecture, and more importantly, the capabilities and the monetization capability. We've got two great guests here to unpack the far edge and what that means for the architecture on the edge. Ellen Salmasi, Chairman, CEO of Veea, an emerging company who's doing some great stuff. Good to see you again. Last time I saw you
great to see you.
New York Stock Exchange, you laid down some great content. We're going to get into it.
Yeah.
Cole Crawford, founder and CEO of SynaptiQ. You guys doing two good pieces of work, formerly of Veea. You've been on theCUBE many times. Of course, back in the old days, OpenStack. First time you came on theCUBE.
Yeah. That's right.
17 years ago? Seems like a long time.
Long time ago.
Great to see you, Cole.
Thank you.
I'm really glad you guys came on, Alan, because I just wrote a piece on theCUBE Research and put it on LinkedIn, I put it on my Substack, I put it on SiliconANGLE, put it everywhere. We see the hyper-converged edge, and inspired by your conversation on theCUBE at our NYSE studio, where you were talking about how the far edge, the wireless piece, combined with the idea of an AI factory coming to the edge. We all see Jensen Huang at NVIDIA and all the compute, XPU players and configuring their boxes and systems in a form factor to come to the edge, which will open up a massive amount of innovation. You're doing some compelling things. I saw some news on the wire from Veea in Mexico. You're doing it. You're hyper-converging the edge right now with Veea.
Absolutely.
Explain what you're doing, the company, why it exists, and why it's relevant to MWC.
John, thank you for having me. It's really a great pleasure to be back with you. Just to give you a little context, over 20 years ago, back in 2003, 2004 timeframe, we partnered with Northrop Grumman, and we won a major public safety bid for New York City that we didn't expect to win. We were competing against Ericsson, Motorola, many of the players in the market. And we built that network between 2004 and 2009, and literally that network was a hyper-converged network, because in order to effectively take care of all of the requirements of first responders, 500,000 cameras that were installed throughout the city, and over 2 million sensors, effectively you needed a hyper-converged type of a network that didn't require any kind of manual intervention, because effectively everything had to be orchestrated. So based on the work that we did, we knew that it's just really a matter of time before machine learning, computer vision, and every application that we were applying to this public safety network is going to come to the commercial market, to effectively type of services that the operators would offer, the type of solutions that would be offered to the enterprises. And so, based on that background, we formed our company back in 2014. So we've been around for 12 years, and literally implementing that vision that started over 24 years ago.
And the demand there was really public safety, homeland security, kind of the things that are needed. That has many services. You never know what you're going to get.
Exactly.
It's not like you're provisioning a VLAN
That's
or
right.
some sort of like static thing. Enter generative AI, Cole. Your work on the real-time side, we documented on theCUBE 2 years ago. Edge, you were already ahead of the curve on that. That's what you're known for, being ahead of the curve. But now, fast forward to today, with cloud native architectures coming in full distributed computing hybrid mode, you now have that coming to the doorstep of the edge.
Yeah, I think, and I think we're here chatting now about AI native. So it's not just cloud native, it's AI native as well. And you look at the convergence or the hyper-convergence of the network, the wireline side, the wireless side, you have a convergence of sensor fusion, right, that is happening kind of everywhere. And so you need to not just manage a network, you need to manage a mesh of networks to manage fleets of devices, all with different constraints, all with different profiles that have different security requirements, different SLA requirements, and frankly, we are, I think, at the beginning of a kind of a functional step in technology where the wireless industry, again, has an opportunity to kind of get out in front, because the radio access network, and this is what I kind of say, your sovereign edge AI factory is only as sovereign as the RF boundary. So, if you want a secure edge, and you want that to be both wireline and wireless, you have to protect the RF, and you have to inference and train next to or on top of that RF.
I think this RF angle, the radio frequency piece, the wireless piece, is super important because it was always kind of like a separate thing. Access was an access method. Right. And I had Cisco's president, G2 Patel on, and Cisco legacy player, leader in routing. Yeah. It's like the elephant in the room. Depending on what seat you sit in, the views are different, right? So if you look at, from a Cisco standpoint, they're the plumbing looking up from the bottom of the stack, wireless looking down from the access side. So agents are coming in, they're talking about agents doing all this stuff and provisioning stuff and doing all these things, with routes and tunnels and all these things. Yeah. That's under the covers. What you're getting at is, with wireless meshing together, you sister up against a factory node. The factory intelligence handles the plumbing and the agents. By the way, and there's a front end piece where the wireless is getting smarter. Unpack this wireless, wireline dynamic, because that seems to be the critical piece of this hyper-converged edge. So it's not network, storage, and compute, the classic definition. It's network, storage, compute, wireless networking, storage, and compute. Right, almost two continents of technology coming together.
Absolutely, I couldn't have said it better, John. Frankly, as these AI agents and automated workflows come to the edge and really become the standard workflow, you really need a mechanism to manage that more efficiently, because there's a growing gap, really major gap between deploying edge infrastructure and operating it. And what we introduced a few days ago in the form of TerraFabric is really the control plane that manages all of these workloads at the edge, and then at the same time, basically makes it more secure and provides for governance of these workloads that at the moment are left up to AI agents, because when they make decisions, they take action, and they interact with physical environment. Ultimately, you need that type of a control plane to manage these AI agents.
So I want to get both your thoughts on this, because I wrote in my piece, hyper-converged originated in the data center as a model, unified storage compute expansion. At the distributed edge, it expands the concept. Multi-access connectivity, fiber, Wi-Fi, 4G, 5G, 6G, heterogeneous compute, you don't know what you're going to get, memory and compute, all good. Local and distributed storage, container orchestration frameworks, embedded cybersecurity services, fleet-wide lifecycle management, AI workload governance. This is the control plane manages those things. That list is a mind-blowing list, just technically. What is the secret sauce to manage all that?
So if you don't mind.
Yeah, please.
We're moving from distribution, right? So you have the distributed edge. We've got distributed power grids. We have distributed co-location facilities today. There are multiple neoclouds and AI companies that are down right now. We have distribution. We have distributed compute. We're moving into a world, especially in this hyper-converged space, where you need to solve for disaggregated, high availability. There's a difference between being fault tolerant and highly available. We have to move to implicitly designing the networks that self-heal, self-optimize, versus the explicit rules of, hey, this packet comes in, put it over there. The world is too big, the devices are too many for us to explicitly define the rules. And you said AI agents, and this is a really hot topic right now. with Moltbot and kind of what's happening. I don't know if you guys read the news of how a bot tried to snipe a developer. You know, to say we're going to solve this by adding a lesser agent monitor a superior agent, I think that's sort of a fool's errand. I really do. So we're in a place where you've got to manage the orchestration of not just the workloads and not just the IoT devices and not just the access points, but also the control plane and the data plane of what these AI agents have access to. And that orchestration is designed at the top and propagated below.
So it's not just throwing compute at networking, it's software-defined orchestration.
Correct.
In disaggregated infrastructure.
Correct.
And what's the fool's errand again, the agent model?
Having a lesser agent. So today, the sort of common, agreed upon approach to solving these very powerful LLMs to keep them in check is to put like a narrow LLM that's supposed to be pretty good at like just monitoring that larger LLM, but that feels a little bit like Jarvis versus Ultron to me.
Okay, Alan, I have to get back to some of the news you mentioned, and I love the wireless side is intriguing to me because wireless was a full-blown infrastructure component. Now it's more like a transceiver access card to the factories and Ethernet backhaul, because backhaul drives, but the radios can mesh with each other. This seems to be the configuration.
Right.
Now your history, for the folks who don't know, you invented CDMA technology. You're the father of wireless. I'll give you the props there. You know, you're very humble.
Very kind.
But as you look at this next generation, what's similar and what's different? Because now the radios will talk to each other in a mesh, that's networking.
Right.
They can be intelligent about communication, but also still manage the backhaul, which the factories want, low latency, high throughput, highly available.
Right. So, you know, for literally the last 50 years, since AT&T, which became AT&T Network Systems and Lucent and all of that, designed the architecture of AMPS, the first analog system. We've had this hierarchical type of architecture where you have switching, which is now the core network, and then you have base stations, which are now more distributed, especially with Open RAN. You have the radio units, the DUs and CUs that are distributed. But that is going to take another leap in terms of how far that distribution is going to go, because effectively by virtue of the complete convergence of wireline and wireless at the core network level, you won't be able to differentiate between optical connections, any landline connections and wireless connections. Now, you know, effectively you can introduce a different type of architecture where those compute elements that were well defined can effectively talk to each other through AI agents back to the core network and effectively increase the RF efficiency and the total throughput and QoS and QoE on a location by location basis, especially as we go up to terahertz types of frequencies.
So this is an architectural change.
A major architectural
Okay, so what's
change.
the impact for the infrastructure refresh? Now I'm connecting the dots from, okay, architecture, to what does it mean for the money making, and what's the spend? Are we in a retrofit, wholesale changes? What's that CapEx edge look like in your mind? Paint a picture.
Right, so you know, ideally, the way all of the network equipment should be deployed is very much like the way we deploy Wi-Fi access points. The only reason that Wi-Fi doesn't work for a outdoor environment at the moment is because it's first come, first serve
Distance,
basis. You know,
throughput.
It's really ad hoc type of communications. It's not managed connections to the users. But there's no reason that Wi-Fi and cellular can converge in a way that ultimately you can deploy this new architecture. Very much like the way we deployed Wi-Fi access.
So seamless access to the user.
Seamless access
I'm on
to the user.
AT&T cellular customer.
Yeah.
I see Wi-Fi, I see cellular, I'm just in. I'm
Right.
in the network.
Right, so anywhere in the city, you can put up a Wi-Fi access point, like type of a gateway or hub, and covers all of the different frequency ranges because now the RF chips pretty much cover from 800 megahertz all the way up to terahertz. And effectively you can have devices that connect to these hubs just like you connect to your Wi-Fi access point at home or at the office. And it's a distributed network, fully distributed network, peer-to-peer. Doesn't have to all go to one location.
And the factories play a key role because the intelligence and the AI sits at the edge with the factory managing the access coming in that's been hyper-converged.
Right.
That's the key point.
That's the key point. And you mentioned, if I could jump in, you mentioned the CapEx. So there's on both ends of the spectrum, no pun intended, there's opportunity. I would say on the CapEx procurement side, we're sitting at a place in the industry that's pretty interesting because there's no reason today you can't virtualize the radio, you can virtualize the baseband unit, you can virtualize every UPF function, but and this might be an unpopular thing to say, John, but
go ahead.
Ericsson and Nokia don't really want that, or Huawei, or anybody that sells hardware. That's not what you want. Typically, you want to move hardware. You've got margins on the hardware, you want to move that hardware. Technically though, you take something like NVIDIA Aerial today, and you can virtualize you can virtualize everything. You can move the CU, the DU, the user plane functions, all of that can be completely virtualized. That would reduce your CapEx cost by 60% out of the gate. Then on the other side is the revenue opportunity for the spectrum owners. Because what I've seen as a person that's in this industry for a long time, not as long as Alan, but a long time, started my career at US West and Quest Communications. So
You've seen the movie.
I cut my teeth on this stuff. I pay less today for 5G than I did for 4G.
Yeah.
And I paid less for 4G than I did for 3G.
Yeah.
So you have to talk about things in terms of return on invested capital. From the telco's perspective, the monthly plan, I don't think is going to mature beyond kind of where it's at today. So the question is there a way to build a futures market on the radio access network? Because at the end of the day, this is all energy, right? Whether it's AI or baseband units or antennas, it's energy. And we know energy has futures markets. So my big bold prediction, John, is we're going to find a different way to monetize the RAN here pretty soon.
I want to get to that.
You can partner with the governments to put that in spectrum.
Well, there's a lot to unpack there, Cole. You just laid down like a 2-hour podcast in like a sentence. So let's take it in two parts. There's the mindset of monetization, selling boxes or monetizing elsewhere. So it's a cultural legacy mindset versus a growth mindset in the modern era. Yeah. The headline of my SiliconANGLE post I'm writing right now is I want to get your reaction to this, is the hyper-converged edge is telecom's next big bet, or its last missed opportunity. Yeah. So I want to get your thoughts on this because the legacy model was cell connectivity, average revenue per circuit, moving from connectivity to managing AI platforms, and then average revenue per service. So you're starting to see different monetization. So will this be an opportunity that the telecom players will get? What has to change? One, do you agree with that? And then if it's a cultural, what's the metric?
Yeah, I'll be happy to take that on. In fact, what Cole just described is what we are demonstrating here at Mobile World Congress. We have a fully virtualized type of a network that is multi-vendor. It's NVIDIA Jetsons, x86 servers, Linux servers, basically various flavors of access points, Raspberry Pis, all as one fully visualized type of a network that with only one middleware that manages every one of these elements that's on the network. You can literally not only orchestrate and effectively manage the workloads and the applications from the edge to the cloud, but you can also introduce any new type of capability in terms of services or applications from any core network on this visualized network, meaning that it can become a common shared type of facility or solution that ultimately multiple operators can offer their services or their solutions or effectively services that they would deliver to the end users.
So Cole, I've been writing about the SaaS apocalypse that's happening, and there's a famous Steve Jobs story I talked about in theCUBE. Former friend who used to work for Steve Jobs said, when I talked about, is AI going to kill SaaS? There's a point here, I'll get to it in a second about telecom. And he said, well, only if they don't make a good product. Like, what do you mean? Well, the value has to be there. He gave the example where when they were building the iPhone in 2005, 2006, released in 2007, the #1 selling product was the iPod.
Yes.
In revenue.
Yep.
Yeah.
They had to kill their own to bring in the new. They cannibalized their existing base.
Yep.
So the iPhone is no longer just an iPod.
Yes, exactly.
It's a phone, it's a computer, it's an app store.
Yep.
So they extracted massive rents from that value.
Yep.
They collapsed and created a new product. They didn't rest on their laurels.
Yep.
So the question is, what does the telecom folks have to do? Because to your point, if they think old legacy mindset, sell more boxes, that's their iPod. What do they have to do? What's their iPhone moment? Is it now? Is this the last missed opportunity, or will someone else come in like SpaceX, AWS? I mean, this is the last stand for telecom, or that's my view, but what's your take?
I personally agree with you. There's nothing preventing a hyperscaler from buying spectrum, nothing. And they've got incredible capital, right? Their cost of capital is low, much lower than your typical telco, at least in the US. So this could be the last missed opportunity, and it will take, again, coming from that world, this will take a cultural shift in thinking. This cannot be about boxes, and it can't be about just layered on services. It's not that either. It's about optimizing a specific vertical. Think about what iPod did. iPod didn't have a camera in it, it just did music really well. So it started with music, and then Apple started adding on. The telcos are in a position today to be able to add on great services for good industries and do those things deep. Today I just feel like it's wide and shallow.
And by the way, the iPod had a lot of users, distribution. Telcos have a footprint. They got towers, they have power, they got connectivity.
That's right.
They have all the physical infrastructure.
That's right.
Small cabinets, big cabinets, but not factories. Not like big data centers in Texas.
Well, no, but they've got the ingredients for those things.
Talk about why this is a killer opportunity given the footprint.
Let's look at, I don't want to say the telco's name because they're, they all kind of came from Bell anyway. We'll take one example, I won't say the name, but they've got, just south of about 3,000 locations across the United States. That's a heck of a lot of footprint. Yeah. Right? There's no reason with a little bit of brownfield retrofit conversion that those central offices and those owned data centers could not be hyper-converged, both locally and nationally. So just because
regionally too.
Totally. A local government might want its data inside of a zip code or inside of a county. A retail giant probably doesn't have that constraint. They might want that to stay in the US because there's no reason to route to anywhere outside of the US for their footprint, but it's the edge is where it needs to be defined on the constraints that it's built for. Whether you're retail, oil and gas, supply chain, logistics, healthcare, everyone's got their sort of requirement for the edge, and the hyper-converged, cloud native, AI native edge. Telcos have this opportunity to solve that.
And Alan, your point about this common network makes that possible. That's what you're getting at.
Exactly, and There's another big driver for all of this, which is the fact that in the US and Western countries, data is growing by 3x between this year and only 2 years from now, 2028. And there's all sorts of
massive
data,
growth.
Massive growth. A lot of it driven by user-generated as well as AI-generated, basically uplinks. And in Central and South America is 2x, but still, you have to build a lot of facilities in order to accommodate that type of a data growth. And so one of the ways to address all of this is to effectively extend the CDN infrastructure that the operators are taking advantage of at the moment to the edge, to the hyper-converged edge. Because now, all of these iCloud backups from every phone that happens at midnight and creates that bottleneck on the network can happen between 2 a.m. and 5 a.m. and no one cares. So now you can effectively manage these uplinks.
Yeah, I just talked with Cisco's president, also lead execs from HP, now Juniper HP. They all have the same view. When I asked, well, NVIDIA's got routing.
Yeah.
They don't have routing. They have routing within the cluster of their AI factories. Because they're routing amongst the nodes.
Yeah.
So networking, to your point, there's routing going on at the edge.
At the edge, yeah.
So the factories have to route among, like NVIDIA has a router inside their cluster.
Right.
The edge is a disaggregated cluster, essentially, virtualized.
And remember, that edge could be a combination of LoRaWAN, Wi-Fi, Bluetooth. It could be a lot. Licensed spectrum, unlicensed spectrum. You can't take a Cisco-like view, and by that I don't mean the company, I mean the box.
Yeah.
You can't take that view, apply it to the edge, and make that work against every factory floor, every coffee house, right?
And so Cisco partners with that edge, just like they partner with NVIDIA. My point is, there's a role for the networking, classic networking,
exactly,
and a new kind of networking emerging.
Exactly.
Mesh for the wireless.
Exactly.
Backhaul through an intelligent factory, talk to another factory, that's routing comes in, NVIDIA does their routing in their factory, is routing at the edge.
Right.
This is the underlying principle.
Yeah, and in fact, John, we announced the tip of that iceberg this morning.
Explain.
So we've been working with American Mobile and Telco for a couple of years, and we just announced that we launched the very first hyper-converged edge box in Mexico. And it's really aimed at ultimately providing for exactly what you described in terms of how iPhone evolved from iPod. And so, they have 5G pretty much throughout most of the major markets in Mexico. They have obviously Telmex, which is the wireline side of the business that offers fiber connections. But there are many parts of Mexico that are still that are unserved.
They're starved for broadband.
No broadband connectivity, right? So what we are introducing is 5G-based broadband access with embedded cybersecurity and applications that can run at the edge.
Hyper-converged.
It's hyper-converged. So it's a virtualized software environment on these boxes that they put into.
And what does that mean for them? What's the benefit to them?
So the biggest win is the increased ARPU on a per household basis. Besides selling the data plan, now they are providing for cybersecurity.
So they get services.
That's
where they're monetized. To your point.
And so what happened was, all these operators had their own walled gardens before iOS came along, right? And then effectively they became dumb pipes after iOS and the Android OS picked up all the revenue from the services and the applications. Now this is a huge opportunity for mobile network operators to get back in the game with this next generation of hyper-converged type of infrastructure.
So they make money on services.
Make money on services, because that's where the money is.
At the same time, they get to simplify their control plane, simplify their data plane, and really, if you think about it, we're really still kind of in Internet 2.0, or at least from an application perspective. You kind of started out with common gateway interfaces, CGI, in the 90s. Then you went to API. We've been using APIs ever since. Now we're going to be in the world of agentic application orchestration. AI native, if you will. To Alan's point, from a cybersecurity standpoint, managing what those agents have access to, think about the monetization of the service. There is a ton of BSS integration that goes into that. So making sure that the right agent has access to the right BSS or the right OSS, this is kind of...
All right, so my last question, I know we're going to run up on time, you guys got to go, appreciate you spending the time. Are the enterprises, which they're saying again this year, more enterprises, say 30% of attendees are enterprises here at MWC, are they demanding something fundamentally different than the carriers, or not, or is it the hyper-converged is indiscriminate on the service?
I think the truth is in the middle. I think the truth is in the middle. I'm reminded of a conversation I had with someone from a hyperscaler who launched a product. They were launching Greengrass. And
it's Amazon.
They didn't think.
Just gave it away.
They didn't think to ask their question, the question of like service on latency, and enterprises said, oh, we just assume that it's because it's cloud, we're going to deal with 100 milliseconds of latency at least. I think enterprises, if offered this capability, would jump on it. I heard Antonio Neri this morning talking, I think on CBS, or Squawk Box, I can't remember which program, but if HP did their QBRs with their large enterprise customers and said, if this existed, would you buy it? With the things we've been talking about here, you would have a major uptake of enterprises adopting sovereign edge AI factories.
Because of latency.
Because of sovereignty. Sometimes latency, but more about if you simplify the control plane, you simplify the data plane, you get that delivered from that provider, enterprises are going to win and they're going to adopt.
Awesome. Last question, has 5G under-delivered? Was the monetization thesis incomplete?
I would say yes, John, because...
on what, both sides? Under-delivered and they're incomplete thesis?
No, it was exactly what it was advertised to be, but it didn't deliver the ROI that the operators were expecting, because at the moment, as Cole mentioned, we are paying less for 5G than we pay for 4G.
It was a negative loss for the carriers, the platform operators.
Negative ROI, mostly because there weren't really any applications that could get the benefit of multi-gigabit types of connections and ultra-low latency, which were the two key features of 5G. And the same thing is going to happen with 6G if this hyper-converged vision that you just espoused for...
so the ROI really is, hyper-converged is going to open up more services for monetization versus selling connectivity, which is declining as it increases in functionality, which is counterintuitive. If you're smiling, what are you smiling?
You ended I'm not going to say this, but if you ended this piece that you're writing right now with stupidity is doing the same thing over and over again and expecting a different result.
Insanity.
I would be.
Insanity.
Well, you just wrote it, so if I do write that, then I'm going to have to say you said it.
No,
I'll just highlight the clip.
Don't.
All right, 6G, Cole. You and I were talking before you came on about 6G. I asked an IBMer about quantum because they're doing a big quantum. Some people have just quantum on their booth, never got traffic. They're not displaying anything, just quantum. Quantum is getting a lot of buzz. What's the quantum 6G? Because 6G, people are trying to squint through. They saw the Nokia, NVIDIA news at their last GTC. People are squinting through. Wait, 6Gs. It's like, it's high throughput, but it's short distance. How's that going to work?
Well, I think it's two things. I think when you talk about quantum in context of telco, there's two things that I think are more appropriate to talk about. There's a lot you could talk about with quantum, but there's two things that I think are really important. Number one, security. 6G with QKD, which is quantum key distribution, you can secure networks and then you are almost immune to attack from the outside because any interference in that quantum link is very, very sensitive, and so you're going to be very secure. The second is around kind of terahertz and where 6G goes. If we look at kind of the mess of millimeter wave, it was tough. We did it, and for in building and these factories, it can make a lot of sense. 6G with terahertz you're going to need things like quantum RF, quantum sensing, in order to propagate and manage that network, not just horizontally across city scale, but vertically in that building that you're deploying. Right? So think DAS on steroids. In terahertz world.
So quantum essentially is going to attack the material side of spectrum.
Definitely.
And radio frequency.
Definitely.
Which is kind of a data computation, but more material science, physics. I mean, I always say you can't break the laws of physics to make things go faster. So you're saying quantum is going to be applied to RF because it's got that physics dimension to it?
It's accuracy for both the physical world and timing. Remember, every radio today has a clock, has an atomic clock in it, right? You need that for timing. You've got GPS-based timing. In atomic clocks, you're measuring things in picoseconds. In quantum clocks, you're measuring things in femtoseconds. So you're 1,000x more accurate. In 6G, when you've got not tens of billions, but hundreds of billions of devices all requiring a different.
Yeah. Well, let's put a pin in that. We'll come back. It's going to be quantum next year. This whole year, quantum's going to be kind of a preamble. I think 2027 here at MWC will probably be a lot of quantum. And hyper-converged, Alan, will be in full swing.
Full swing.
The telecom AI infrastructure reset is here. Thanks for coming on. Thanks for this extended segment.
Thank you for having us.
Appreciate you.
John.
I'm John Furrier at theCUBE. The hyper-converged edge, I just wrote a post on this. It's coming fast. This is the preamble to physical AI, quantum, telecom, quantum wireless, whatever you want to call it, quantum infrastructure, secure, low latency, continues to be the theme. We'll be right back with more coverage after this short break.